Hi students, today we are going to discuss about different types of function. First one is 1-1 function. Take a look at this diagram. It is the arrow diagram of a function f1 from a to b. Representing the given function in roster form, we get a set with four ordered pairs. And that is equal to f1 equal to the set containing elements ordered pairs. First ordered pair is 1a and second ordered pair will be 2b and third ordered pair will be 3c and fourth one is 4d. Okay, if we observe the set, we can notice that the different elements from set A have corresponding with the different elements from set B. That means the image of different elements of set A under F1, under function F1 from set are different. That means the images of different elements of set A under the function f1 are different. We can also say that no two ordered pairs have the same second coordinate. Now take a look at this diagram. In this case also, the image of all the distinct elements of set A under the function f2 are distinct, or no two ordered pairs have the same second coordinate. Such type of functions are known as 1-1 function. Let us define it mathematically now. A function from a to b is defined to be 1-1 if the images of the distinct elements of A under the function f are distinct. That is, for every x1, x2 is an element of A, f of x1 equal to f of x2, which implies x1 equal to x2. So, note that condition. x1, for every x1, x2 is an element of A, f of x1 equal to f of x2, which implies x1 equal to x2. This is a condition for 1-1 function. Okay. And 1-1 function is also known as injective function or simply injection. Further, if a function is not 1-1, then it is known as many one. Okay. For example, the function f shown here is not 1-1. Here we can see that the distinct element 3 and 4 of set A have the same image -3 under the function f. So it is not 1-1, hence the function f is many one. Now look at this question. Here two functions are given and we need to check the given functions are 1-1 or not. Now let us first consider the function f. We know that the function can be either represented by this way or represent the given function in arrow diagram. Okay. In first case, we can see that the different elements have different images. Therefore, the given function is 1-1. Similarly, next consider the function g. So let us write in this way. we get g of minus 1 equal to 2, g of 0 equal to 4, g of 9 equal to minus 4, g of 9 equal to minus 4. Next, g of 18 equal to 6. Last one, g of 23 equal to minus 4. G of 23 equal to minus 4. And the arrow diagram of the function g will be like this. So first we write here minus 1, 0, 9, 18, 23. Next 2, 4, minus 4, 6. Okay. Next we start to draw our arrows. Minus 1 to 2, minus 1 to 2, 0 to 4, 0 to 4, 9 to minus 4, 9 to minus 4, 18 to 6, 18 to 6, 23 to minus 4, 23 to minus 4. Okay. In the second case, the image of 9 and 23 is minus 4. Okay, and it means g of 9 and g of 23 equal to minus 4. Hence, the function g is not 1, 1. Okay, it is not 1, 1. So here it clearly see that the two elements of set A are mapped to the same element of set B. Okay, so here the function is not 1, 1. Here is our next question. In this question, we need to show that the function f from R to R defined by f of x equal to 2x is 1, 1. So, let x1 comma x2 be any two arbitrary element from domain R from the function f, such that f of x1 equal to f of x2. Now, here is our f of x equal to 2x. So, f of x1 become 2x1 and f of x2 become 2x2. By substituting these two values to our condition, we get f of x1 equal to f of x2 become 2x1 equal to 2x2. Cancel these two each other and we get x1 equal to x2. Hence, any two arbitrary elements x1 comma x2 in the domain of f of x1 equal to f of x2, which implies x1 equal to x2 for all x1 comma x2 is an element of our domain R from the function f. Therefore, f is 1, 1. So, we get our function is 1, 1 function. Second function is onto functions. Let's begin by considering a function f from A to B, as shown here. From our previous knowledge, what will be the values of domain, codomain and range. And we know that domain is the set A with elements of 1, 2, 3, 4. Okay, and codomain is the set to B with the elements 5, 6, 7. Range is the set to be of the elements 5, 6, 7. From this we can see that the codomain of function f is equal to range of function f. Right? Codomain is equal to range of function f. These functions are known as onto function. Mathematically, a function f from set A to set B is said to be onto if and only if for every element y of B there is an element such that f of x equal to y. This implies that for every y is an element of B, or in the codomain that exists at least one x in the domain. So the range of function equal to codomain of that function. Hence, the function f is onto if and only if f of a equal to b. The other name of an onto function is surjective function or simply surjection. For example, let us first consider the function from a to b, function f from a to b. The function in which two elements are mapped to the same elements are also onto, provided there exists a pre-image of every element in the codomain of the function f. So here the f is onto, and it is very clear that the two elements here 3 and 5 mapped to the same elements 11 here. Okay, provided there exists a pre-image of every element in the codomain of the function f. So it is function, therefore we can say that f is onto. Now let us consider the function g from a to b. However, g is not an onto function, since the element 4 here in the codomain of the function g not have any pre-image in the domain. Hence, we can say that g is not onto, not an onto function. Okay. Next type is bijective function. We have learned a function f from a to b is defined to be 1, 1 if every element of a is mapped to a unique element of b. That is, no two elements of a are mapped to the same element of b. Okay, here the function f satisfying this condition, that is, we can see that f of a equal to 4, here f of b equal to 2, f of c equal to 1, f of d equal to 3. So we can say that this function is 1, 1. And we have also learned that a function f from a to b is said to be onto if for every element y of b, there is an element x in A such that f of x equal to y. Here this function f satisfies this condition also, and hence it is also an onto function. Thus, the function f from A to B is both 1, 1 and onto. Such a function is also known as a bijective function. Mathematically, a function f from A to B is said to be a bijective if it is both 1, 1 and onto. I hope you understood.